In this video, I'll talk about some of the basics of periodic classification of the elements. We're asked to specify in what group of the periodic table each of these elements is found. The first one is the helium core plus the 2s2. So the helium core, that says start with helium. That is the atomic number 2, so 2 electrons plus 2 more electrons right here. So 2 plus 2 gives us 4 electrons, and that is the atomic number 4 for beryllium. So beryllium is in group 2. So we could say that this is in group 2. Now that's more of the contemporary numbering, this 1 through 18. Some of the, I'll say older or traditional numbering would be group 2A. So just for your reference, you can probably, I'm sure you can still find periodic tables that have this 1A, 2A, and so on numbering of the groups. Now the next one, the electron configuration, is the neon core plus another 2 plus 2. So neon, the neon element, has an atomic number of 10 plus 2 plus 2. So 10 plus 2 plus 2 is 14, and that element with the atomic number of 14 is silicon. So silicon has 14 electrons, and it is in group 14, silicon. So we'll say group 14 for the silicon atom, or in the traditional grouping, that would be 4A. Next, the neon core, again starting with 10 electrons plus the 2 plus the 6, so 10 plus 2 plus 6 equals 18, so the atomic number 18. And argon. Argon is the element here, and it is in group 18. Now, this is just a coincidence. I realize the last two were in, we had atomic number 14 and atomic number 18, and those are also the same group names, but that's, you're not going to have the atomic number, or the number that you get here. It's not always going to be the group number. It just so happened in both of those examples. Now, traditional labeling of the groups for this one would be 8A. The last one, xenon core, so that is atomic number 54. So you have 54 electrons plus the 2 plus the 14 plus the 4. So plus 2 plus 14 plus 4. That's xenon 6s2, 4f14, 5d4. Add all of those up and you get 74. 74 is element tungsten, atomic number 74, and it is in group 6. Tungsten is in group 6, so we'll write that, group 6, or the traditional grouping that would be in 6B. Now, one quick thing I want to note, I want to give good credit to this reference table that we are using. It's found at ptable.com. I certainly should and would like to give them credit because this person, Michael Dea, did a good job, I believe. But I want to go to orbitals and then show you some of the academics of how these are classified. You see that if you have an electron configuration ending in S, in an S subshell, then this in groups 1 or 2. If you have an electron configuration ending in P, these are all the orange ones, and let's click on one. So for oxygen, you get a subshell of 2P being the ending, the electron configuration. So that's all of these in groups 13 through 18. Group all the metallics, the metals, ending in D. Here's the lanthanide and actinide as well, and the rest of the lanthanides and actinides ending in F. Their electron configurations. I'll click on one here. Their electron configurations ending in F. There's one. So that's just a good look at another way to organize this periodic table. By the way, the lanthanides and actinides are their own groups. They don't fit into one of these 1 through 18 groups. I hope you did find that helpful. If you did, consider liking it or sharing it with a friend.